Hello, I have like 1, 2, 3, 5 people here after school. We have Laura, we have Jackie, Jack, big on J's today. We have, what's your name?
Tom.
No, Tom, I'm kidding. And we have Leif Erickson, okay. I did this problem during the day, so this is going to be a little bit different from what you may remember in class. I just didn't do it well, so I want to redo it. This is B5, Eben. Eben lifts an engine out of his Volkswagen, people's car, Volkswagen, with the help of a winch that allows him to raise the engine 0.02 meters for every 0.9 meters he pulls on the cable. Eben expends 1,000 joules of energy to lift the 800 Newton engine 0.5 meters. What is the efficiency of the winch? What is the ideal mechanical advantage of the winch? What is the actual mechanical advantage of the winch? And what force does Eben exert to lift the engine? Let me just read the value part again. 0.9 meters of cable to lift it 0.02. So you need this much cable. Can you see that? You need this much cable to move it over here. That's 2 centimeters. This to here, these 2 fingers here, that's 0.9. So we need 0.9 meters to move it 2 centimeters. That's 2 centimeters. That's 2 centimeters. Get it? Mm-hmm. Understood?
Yes.
Okay. So DI theoretical, DO theoretical is going to be 0.9 and 0.02. 0.9 is DI, 0.02 is DO. Now, what else does it say? It says Eben expends 1,000 joules. So that's the amount of energy he's putting into this. For the job to get done, he's putting 1,000 joules into that. Do you understand why that means in? So the engine operator puts the work in. The machine gives it back. That's the output. Machine gives it out. Operator puts it in. Right? Okay. It's like you put in a coin. It's like a bubblegum machine. You put the coin in the slot. Right. That's the input, and the output is the gumball. Understood? All right. And the machine has a weight of 800 newtons. I'm not going to move at 0.9. I'm going to move at 0.5. So that's going to be, I'm going to move at 0.5 vertical. Correct? I'm going to move at 0.5 vertical. Correct? I'm not going to move at 0.9. I'm not going to move at 0.02. I'm going to move at 0.9. So what is 0.5? Is that DO or DI? Is that how much cable I'm using, or is that how much height? Is that the height I'm lifting the engine? That's the height I'm lifting the engine, so that's going to be DO, right?
Yes.
Which is a smaller value than the DI, isn't it?
Yes.
Correct? Okay. And then what else do we have? That's it. Okay, now, what I've done is I made a table here. Okay, so let's fill in what we have. 800 newtons is what?
Mass.
No,
FW.
800 newtons.
FW.
What's the giveaway? FW. Newtons is force, right? So that's 800. 800 newtons. What's FO? 800 newtons. Good. What's FI real? What's the input? Well, we don't want to know that yet. Let's skip that for just a minute. Okay, that's something we have to calculate. This isn't listed in necessarily order in which we're calculating these. Okay. What's 1,000 joules? What was the 1,000 joules?
Work.
Input, right? Wasn't that the real work input?
Yes.
Yes? Okay. So that was, do I have it?
It's up there.
Here, right here. Work is joules, right? 1,000 joules. Okay, good. What else was I given? I was given 0.5. What was 0.5?
DO.
DO. Okay. Was I given anything else? DI, no, I wasn't given DI. I was given a possible DI. In other words, if I wanted to move it 0.9, if I wanted to use 0.9 meters of cable to move it 0.01 meters. So what was I indirectly given? IMA or AMA?
IMA.
I was given IMA. In other words, right here. I was given, remember, IMA is DI over DO, right? So I was given the ratio, which is because it's ideal, the ratio remains constant, right? You get it? So I was given, let me erase this part there, okay? I was given 0.9 over 0.02, right? Wasn't I? That's meters. Excuse me that's going to be 0.9 meters over 0.02 meters equals 45.
Yes.
You mind if all right, I'll just do this. We're running out of room here, okay? I want to use this as my workspace. All right, so 45, right? Correct?
Yes.
45, all right. So what's my DI then? Can I do my DI? What's my DI? See, my DO here would be 0.02 if my DI were 0.9, right? But my DI isn't 0.9, it's something else. My DO is going to be 0.5. So let me put in 0.5 here. I'm going to work right here. Is that okay? I'm going to use this as my workplace. So in other words, IMA equals DI over DO, correct?
Yes.
So I know my IMA is 45, and that's DI, right? And I know my DO is going to be
0.5.
0.5, right? 0.5. So then my DI must be, for this particular experiment, my DI must be 22.5. Do you see that, Jack?
Yes.
Okay, so my DI is going to be 22.5 meters. Can I erase some of this here? Can I erase this here?
Yes.
Mind if I erase that? So I know that the IMA is 45. Are you okay with that?
Yes.
Yes.
Okay, good. Do I have enough information yet for AMA?
No.
No, not yet. Okay, good. All right, now, what else? Now I have DO and I have FO, right? Therefore, what can I calculate? WO. So WO is, so let me erase this, right? And I can extend this line over, right? Easy. So I know that work output equals FODO. So work output equals
400.
800 times 0.5.
400 joules.
Stole my answer.
That's the first time I ever heard Tom speak. He told me he was from Romania. You sound like you have a Midwestern accent. I've never heard him speak before, and he shouted at me. Excellent, Tom. Excellent. Well done. Point. So the work output equals 400 joules, right? Isn't that correct? The work output is 400 joules? They're having a good time in physics after school. Very weird. Okay. So work output, where's that? Do I have work output?
Yes.
Where's work output?
400 joules.
I know that, but is it listed on our thing?
No,
It's not listed?
I have
Okay.
it.
So WO was not listed in the original table, so we've got to do that. Okay? So WO equals what? 400 joules. Okay? All right? Got it? Okay? So let's put our workspace back. Hopefully you're going to be able to see. Can you see 400 joules, do you
Yeah.
think? Can you see
Yeah.
that?
Yes.
Up there? Okay, good. All right, so now, good. What is work input? Real?
Well, we don't know yet.
Yeah,
Yes, you
we
did.
know
We
that.
gotta find it.
We know. No. We were given it, right?
Oh, we worked
Let me remind you. It says it says, Eben expends
1,000 joules.
1,000 joules.
So
Excellent,
that's work
Thomas.
input.
That's your that's your work input. He's
Yeah.
crazy today. It's
Man,
unbelievable.
You are crazy.
Excellent. Excellent. My goodness. Okay. Now, so if listen, if the work input is 1,000 joules and the work output is 400 joules, is there anything based upon your equations that you can now calculate? All right, we can do ideal. All right, let's do that. What's the work input ideal? Okay, Jackie? 400 joules. Okay, good. Now, what else can we calculate? We'll take a sip of coffee here. What else? What is it?
WF.
Okay, WF, good. We can do WF. If you put in 1,000 joules and you only need 400,
That's 400 left. Oh, 600.
it would be 600. It would be 600. So this would be 600 joules. Okay, right? What else can we do? Anything else? So what's the work net? Isn't that the same as something up there? We have some repetitive things up there.
Well, you just have to add
No.
work real.
No. In other words, what work was done? What was the net work done to actually do the job? No. What is it? No. That was the total amount of energy put in.
400.
But what, exactly, in other words, if you subtract, listen carefully, if you subtract the friction from the total amount, that's going to be the net force, correct? The net work, right? So that's going to be what? That's going to be, W net is going to be 400 joules, correct?
Yep.
Okay, what's the mass?
We didn't get that.
Yeah, but you can calculate it.
Oh, isn't it 800 divided by 10?
Yes, which is
80.
80 what?
Kilograms.
Kilograms.
80 kilograms. Okay, now what is how do I calculate efficiency? There are two ways.
Isn't it AMA over IMA?
Yes, but we don't have the AMA yet, right?
Work output divided by work input.
All right, work output, efficiency equals work output over work input, which is going to be what over what?
400 over 400? Oh, 1,000.
Which equals what?
0.4.
0.4. So the efficiency is 0.4, correct?
Yeah.
All right, now, what's another equation for the efficiency? Jackie, somebody just said it. Yes.
AMA over IMA.
I just said
AMA, yes, I know you just said it, Tom, but we didn't have enough information to use it at that point, right? Okay? So AMA over IMA. Now, do we have two of those three?
Yes.
What do we have?
IMA.
Efficiency and IMA, correct?
Yes.
So, let me erase this here, okay? So we can calculate the AMA, can't we?
Yes.
Can we calculate the AMA?
Yes.
All right, so, wait a second. Let's not get carried away. Efficiency equals AMA over IMA. So 0.4 equals AMA
Over
over 45.
Yes.
So AMA will be what?
18.
What is it?
18.
0.4
18.
times 45 is
18.
18. That's absolutely correct. So the AMA
You doubted me.
equals 18. What is it?
You doubted me.
No, I didn't. I just want to make sure that you were convinced. Okay. So this is 18 then, right?
Yep.
What are the unit labels for AMA and IMA?
There is
There
none.
is none.
There aren't any. Excellent.
Yeah.
Yes. Excellent. Now, if the AMA equals 18. What's another way of calculating the AMA?
F.
AMA
FO over FI.
equals FO over FI. Do we know two of the three?
Yes.
What do we know?
AMA and FO.
We know AMA and FO.
Yes.
If the camera goes off, I'll just
Keep going.
I'll just reset it and
Do another
right.
part.
Okay. So it's going to be 18 equals what's FO?
800
800. This is
newtons.
newtons over what? FI, right?
Yeah.
Right? So what is FI equals 800 divided by 18, is that right?
Yeah.
I'm exchanging FI and 18, so 800 divided by 18 is 44.4 newtons, is that correct?
Yeah.
Yes? Okay, so that's going to be where?
Fi.
FI
Real.
real, okay? So that's, what did it say?
44.4 Newton.
44 point what?
Newtons.
Newtons, excellent. Now, what's the ideal force? What did I actually use? What's the ideal force? Let me erase this. What would the ideal force be? Isn't that based on the ideal machine equation?
Is it 755.6?
Well, let's see. Let's examine it, okay? I know that work output equals work input, correct? Gentlemen, work output equals work input, correct?
Yes.
Okay, now, FO DO equals FI DI, is that correct? Right, we're looking for FI ideal, right? And this is the ideal machine equation. So when we calculate that FI, that will be the ideal, correct? Yes or no?
Yes.
Yes, okay, good. So FO is 800, right?
Yeah.
800 times 0.5.
Yeah.
I'm going to leave off the unit labels, is that okay? Excellent. Equals FI, and what's DI?
DI.
22.5.
So what is 800 times 0.5 divided by 22.5?
Oh, I was way off. 17.7.
17.7.
I was like 700 off.
That's okay, it was,
I did. I thought it was 800 minus 44.4 mainly because he said that's what it was.
Excuses.
So I copied off of Jack.
well, but what you're doing is you're comparing FO and FI. You have to compare FI real with FI ideal.
Yeah.
You get it? Okay. So what's the friction? What's the friction?
Friction is.
How do I calculate the friction? Isn't the friction,
You could do F over Fn.
isn't it gonna be the difference here? Is it gonna be the
How can we do it?
FI real minus FI ideal? Isn't it?
Yeah.
So friction is gonna be 44.4 minus 17.7. Is that still working?
Yeah.
Okay. So what is it?
26.7.
Mm-hmm.
26.7 newtons. So that's the friction, okay? 27.7 newtons, okay? What's the F net? What's the F net?
FP plus F.
What, no, think about it, there's no FP.
Oh, there isn't?
What's F net?
I don't know that.
Well, yes you do.
F net.
Fp plus Fn.
What's F net?
F net is all of the F's. I don't know. Real, FI real. I don't know. I have no
Well,
idea.
we don't have acceleration.
No, you don't need that. In other words, isn't the F net the force I used minus the frictional part of that force? Isn't that the F net? So what does the F net equal up here? What is it the same as?
FI ideal.
Fi ideal. You get that?
Robin answers.
They have to be equal, don't they?
Yeah.
Correct? Okay, I gotta leave soon, so I have a dentist appointment. My teeth. Okay, so what's gonna be the change in, can you see this up here, guys, on the film?
Yeah.
Yeah.
Okay, what is the change in kinetic energy? The total change. It's on there, it's on the board already in a different form. In other words, what's the total kinetic energy I must have started with?
1,000
Some of,
joules.
I didn't even finish the sentence and he answered the question.
You're gonna confuse the.
Excellent, excellent. Okay, okay. So, minus or plus 1,000 joules?
Oh.
Minus.
Minus.
Yeah.
So, in other words, the total energy you put in. Some was converted to heat through friction, but some of the initial kinetic energy was actually used to do the job. Correct? But the total was 1,000. Right? Now, what's the increase in potential energy?
Isn't it plus 1,000 joules?
No.
I thought it was the opposite of.
No, listen to me. Potential energy is very simple. Potential energy is mgh.
Oh.
What's mg? What is mg given on the board there? What's mg? 800 newtons, right?
Yeah.
What's h?
Do.
No, yes, do.
So it's
So-
400.
400 joules, exactly.
So smart.
Now, listen carefully. Let's say that it took 20 seconds. It took 20 seconds to do this job. It took 20 seconds. What's the total power for the job? It took 20 seconds. We're saying it took 20 seconds to do this job. Power equals
Work divided by two.
work over time. So power equals 1,000 over 20 seconds, which equals what?
Yeah, Jack.
Jack got it, 50 watts.
Everyone's amazing but me.
50 watts. And what is Watts named after?
James Watt.
Mr. Watts. Exactly, James Watt. Okay? That's it. Have a great day.
Thank you.
Hey, be careful of the Canadian geese. Okay? Don't look up.
They're my friends.
Have a great day and goodbye. See ya.
This is yours.
I chase
Everybody
after.
knows the Canadian geese is the most dangerous animal.